Welcome to this video on structures and union in C. I am Smita Suresh Daniel, Assistant Professor, St. Thomas College, Bhilai. This lecture is for BCA first year students for Unit 3, Array and Structures in C language. We have already learned about arrays, which represent a group of data items that belong to same data type such as int or float. However, we cannot use an array if we want to represent a collection of data items of different data types. And using different data types using a single name. Fortunately, C constructed a data type known as structures. A structure is a convenient tool for handling a group of logically related data items. For example, it can be used to represent a set of attributes such as student name, roll number, marks, etc. in a combined form, which can be called as a record in another language. The first question which we will discuss here is what is a structure and how to declare a structure. Structure is a collection of logically related data items of different data types grouped together under a single name. This means a structure can be created with a collection of logically related data items. For example, we want to create a structure called student. A student has many attributes. All these attributes can be combined together to form a data structure. Structure helps to organize complex data into a meaningful way. The syntax for structure is written here. It starts with the keyword struct. Then the name of the structure has to be written down. All the data members has to be mentioned here between the curly bracket open and curly bracket close with a semicolon. This creates a user-defined data type called structure. These are the members which should be defined with its data type. Here we explain structure with an example. We can learn how to create a structure. Look into this program. We have created a structure called book. In this, we have space for the title of the book, author's name, and int pages, number of pages we require, and the price of the. So all these four data types will be combined similar to the format of an array. Sequentially, these data type will be arranged one after the other according to its size. So you have created a user-defined data type here called struct. Now coming into the main program, we can just create variables for this structure in this format. Struct book is the user-defined data type and book1 is a variable which we require to create using a structure. Here we see that book1 is a variable of the data type struct book. Now, as we go into the program, we can see how to enter values to this variable. This variable comprises of many attributes like the title, author, pages, and price. All these can be inputted by using a dot operator which connects the variable book1 with its related attribute. For example, the first title is to be entered. So how do we write this is book 1 dot title. This will create a space in the memory location for writing the title of the book. Then comes the author. Immediately after this, another memory location will be created for writing the author name. Then, in a sequence, all the data is entered one after the other. The dot operator plays a major role to connect these attributes to this variable. So, we have entered the values for the book 1. All the details of the book 1 are combined together into a struct known as book 1. Now if you want to print this, similarly you can use printf statement, book 1 dot title, book 1 dot author. This will provide whatever information you have entered for the first 4 lines of this program. So you will see the result as the title, author and page and price of the book given by you. So this is the way we create a structure. Structure is a very useful thing which we have to enter and store data in a systematic way in the form of a record. Now let's learn how to declare and assess structure variables. We have already seen an example, and this is a declaration format. There are 2 ways to declare it. First, you create a structure with all the attributes. Then you can give the variable name as book 1 right before ending the semicolon here. This is one way of creating a variable, or else if this is not a local variable, this is the struct book is the global variable which you have created, then inside the program you can create struct book. This same line has to be written, then book 2, the variable for struct book. Both the ways you can create variables for the structure. Now let's learn how to access a structure member. As I told you earlier with an example, accessing a member of a structure or an attribute of a structure is done with the help of the dot operator. This operator will connect you with the attribute or the member. The format for doing is the structure variable, whatever it is, dot the member name. For example, you want to connect to the book 1 dot title. Here book 1 dot title means the title attribute of book 1. Book 1 dot author and book 1 dot pages. All these dot operators are used to connect with the attributes of the structure. Next, we will learn about nested structure with an example. Nested structure contains a structure within a structure. Structure which is part of other structure must be declared before the structure in which it is used. So let's see again with an example here. This example is also creating a structure called address. Similarly, another structure is created whose name is employee. Now, these are 2 different structures, but we can see that there is another structure which is using the data type or structure address within another structure. This line you can see carefully, structure address A. This means this is a struct address which is not a part of this structure but the structure which is above the employee structure. So you have created a variable for it and the other variables are there. So you can also create structure variables within another structure. In order to access the members of a structure within a structure, we will see the example given here. Like suppose now you want to create a structure employee object, variable E here. This is a variable of struct employee. So enter name, address, city and salary. We will see the address part here. The address part is given here as address has three different attributes. So each one have to be added. The first one is E dot A. E dot A is the variable name. E is the main variable name. This is accessing the variable A here, dot A dot. Now A has to access each of the attributes here. So we have A dot A1, A dot A2 and A dot city. All these three are accessed. We used two dots to connect all the members one after the other. So here is the first part. Similarly, if you want to display it, you can use the same dot operator. When you are entering the data in these variables, this will be stored in the format of an array one after the other. And if we want to access it, we can use a printf statement to print it on the screen. So the same format can be used for using the output here. Explain array of structures with an example. Let's see what we mean by array of structure. As for now, we have learned only to create one variable or a two variable separately. But sometimes we need to create many structure variables at the same time, just like an array. Let's see this with an example. In this example, a structure is created called result. It has so many members. Now, all these members can be stored in an object or a variable of struct result. For example, this statement, let's see this statement carefully. Struct result R66. R66 is just like an array which we had already learned how to create an array. There are 66 different variables of the result kept in a sequence, one after the other. All are having, each one is having space for all these three members. Like for example, let's see how we can enter the details of the student's result. We have to form a loop for storing 66 different results for each student. Here we enter name, roll number and CPI. As soon as this statement we can enter the name R1 RI dot name. Ith value is the first value, so R0 dot name, R0 dot roll number and R0 dot CPI. The first student's results is entered in the same way as we had seen in the earlier example. In this way, the I value will change from 0 to 65 and each time one particular student's results will be completely entered into the array. This is nothing different from an array, but only difference is that the array is storing in each block all the members of the struct result. Here we see that one particular block will be using 100 bytes plus 2 bytes plus 4 bytes. Around 106 bytes will be used to store the complete detail of the result of a student. Similarly, each block will be having similar capacity. So this is known as array of structures. Now let's understand what do we mean by pointers to a structure. Just as we have learned earlier what a pointer is and how it is pointing towards a simple data type variable. Similarly, here also there is no much difference. A pointer created will be of the same data type which will point to a variable of a struct type. Here we see a structure and we have variable known as struct name and another struct name. In order to create a pointer, you need to put a star and struct pointer. So we have created a pointer variable which will be storing the address of another variable in a structure. Now we can see this example. We have created a book structure which has only one member and you have created a pointer variable. Now, once we have created a pointer variable, we use the ampersand operator to access the address or store the address of a variable, structure variable into a structure pointer. This is just similar to how we had been using a simple pointer and storing the address of another variable into a pointer variable. So this is the way we can use to store the address of the structure into a pointer variable. Similarly, if you want to access the member of a structure using a pointer, we need to use an arrow operator. Arrow operator. Instead of dot operator, we use an arrow operator. If you are using a pointer, always use an arrow operator, not a dot operator. So this will access the members of a structure using a pointer. So this is an example showing the pointer of a structure. Let's go through this example. This is a small structure which we have created with only just two variables, and inside the main program, struct name pointer variable is created and a simple variable for a structure is created. These are two variables. Let's see how this pointer variable will be accessing the address of P. So in order to reference a pointer to its memory, we use ampersand P. Ampersand P is the address of the variable struct P and this is stored in a pointer. Now the address of P is stored in the pointer variable. Now address of P can be, you can see you can enter the value, any integer for a given member using a pointer. Address of asterisk pointer dot A means pointer is storing the address of P and in that address Through that address, we are accessing the member in this way. Similarly, all the pointer addresses will also point to its members using a dot operator. Writing bracket, writing the pointer variable within a bracket dot a is same as writing ptr arrow a. These both in these both way we can access the members directly. In the next part we will learn what is a union. Union is a user defined data type just like a structure but with a little difference. Here we see that each member in the structure is assigned its own unique storage area. In a structure we see that different members will be stored in a having all they all have the same they all have different space allocated, but in union it's a bit different. All members share a common area, so only one member can be active at a time. Not all the members can be used at a given time. Unions are used when all the members are not assigned value at the same time. Sometimes it happens that we don't require all the members for use in our program. So why should we take a lot of space for storing all the details? So union is there, which will help you to take only some of the variables or members of a union. Let's see this with an example. Here, union. This is the union. See, union has A, B and C, three different variables. So the highest variable is 4 bytes given to the union. Means the highest float value will take 4 bytes. So it has to use this 4 bytes to accommodate any of the variables in this union. It will be provided only with 4 bytes because only at a time one of the variables from the union will be used. Rest can use this space for storing the information. Here it's a bit different. In structure, each variable is having its own space. 1 byte for C, character takes 1 byte, 2 bytes for A, int takes 2 bytes and float takes 4 bytes. In total, it will take 7 bytes. So here is the difference between union and a structure. The space provided will be the union of all the members in a union. So it will be giving a common space, but here structure it has a sum of all the memory requirement for all the members. So this is the difference between a structure and a union. We can see the first point. Each member is assigned its own unique storage area. All members share the same storage area. So sharing is there, little space is required. Total memory required by all members is allocated, but in union only maximum memory required by the member is allocated. Here we see that all members are active at a time, but here we see that only one member is active at a time. One of the 3 members will be active here. All members can be initialized. Only first member can be initialized in a union. It requires more memory, as we have seen that all the members require space, but here requires less memory as a union of the all the three memory is taken. Thank you.